be pretty easy. And then we got this group assignment coming up. That's mostly what I want to focus on today, is an easier way to do this group assignment. All right, I'm going to do that by doing one of the homework problems. And I'm going to answer a bunch of questions that they didn't even ask here. Let's see, which one was it that I'm doing? Should start with the 3052. Yeah. Okay, so your calculator will do linear regression. It does it just fine. I want to make sure I'm recording. Yeah. We can do all this in the calculator, but honestly, Microsoft Excel is a little better at doing linear regression because it will automatically generate a regression line for us. Like, we don't have to do any extra step. Well, I guess there are a couple extra steps, but it produces a nice graph that then we can copy and paste. So I'm going to do this problem in Excel. So first off, let's read the question. If you're watching this recording, pause and actually read the question. Okay, so here X is not our year. X stands for years after the year 2000. Anytime we're doing linear regression, if possible, we want to make sure that the origin appears in our graph. So if I actually use the years 2002, 2003, and so forth, and I'm drawing, say I'm plotting my points, this is 0 right here. If I wanted to plot stuff like 2002, 2003, and so forth, if I'm going by ones, 1, 2, 3, imagine where 2002 would be. It would be way over there. And all my points would be over here somewhere. Now, sometimes you'll see people do this little broken axis thing. They'll do this little, even your book does this sometimes. Well, they'll do a broken axis where this is meant to represent a big old chunk of missing stuff. So here was 0, and then all of a sudden here's 2002, 2003, and so forth. And again, I'm not saying this is something that's always wrong. Your book even does it. But it's not a good practice, because then when you graph, you plot your points, you draw your line, all of this part of your line right there is just crap. It's not true. This little section right there represents 2,000 years. So our y-intercept, whatever our y-intercept looks like is on the picture, is completely wrong, because none of this graph here is right. So it's much better, if possible, to start your graph at 0. Start your x's at 0. So that's what they're forcing us to do here. Instead of having the actual year, we started our clock at the year 2000. X equals 0 represents the year 2000. So this guy right there, that would be 2009. Then when I draw a graph, all of my data points will fit right here in this region, right near the origin. And when I draw a line that fits through them, my y-intercept, I can visually see, it makes sense to me, and it's accurate. It'll just represent the, in this case, the temperature in the year 2000. So you have this group assignment coming up. This is the way I want you to do it. I'm going to talk about that again in a minute. Okay, so here are all of our data points. So I've entered these into Excel, and I put labels on. So my X's were the year after 2000. And then these temperatures, they don't tell us in the problem, but I'm assuming these are temperatures in Celsius, degrees Celsius, because these are high temperatures. Those don't make sense to me as highs in Fahrenheit, unless this is like, you know, Antarctica or something. So I've entered them all in, and let me show you a trick here. Here's how I entered them. I wasn't even sure if this would work, but it did. I just used my mouse and highlighted both of those columns and hit copy. Then I came over here, picked the cell, hit paste, and it pasted everything for me. So it's so much easier than typing them one at a time. Okay, now Excel will find my line of best fit for me. Notice, by the way, I did this just for your benefit. I put what that X actually means, like X equals 5 means the year 2005. But these are the ones I'm going to be plotting. If I'm plotting these numbers, I'm going to get a graph that doesn't make any sense. I want to plot these numbers. So the way I'm going to do that is I'm going to just highlight all of those. Notice again that I put labels on here so that Excel will automatically put those labels on my graph. And now every version of Excel is different. Like if you downloaded Excel today, the buttons may be a little different than what I'm doing. You're going to have to figure out your own Excel. If you're on a Mac versus if you're on a PC, the buttons are a little bit different, but here's how it works on mine. I hit Insert, Chart, and I want a scatter plot right here. And it did a nice scatter plot for me. And notice it went ahead and put a label on it. Okay, now I can make it find my line of best fit by going to Add Chart Element. Again, in your program, the button may be in a different place. You may need to search around and find it. But here, mine is right here, Add Chart Element. I'm going to add the axes in a minute, but what I want to add right now is the trend line. And I want a linear trend line. And I want it to tell me, so I have to do that and then come back and go here again and go to more trend line options. So I added it, I go to more options, and I tell it right here, display the equation, display R squared. Okay, so now I can come in here and move those out of my way. I'm just trying to grab that equation and move it so it's not in the way. There we go. Okay, now there's our equation. There's our R squared. It won't give me R. I'm going to have to do a little math to figure out R, my correlation coefficient, just by taking the square root. But here's my slope. There's my y coordinate of my y-intercept. Now I'm also, for completeness here, I'm going to go ahead and add on my labels. So add chart element, my axes, titles. So my horizontal axis was year after the year 2000. And then my vertical axis, axis title there. Was degrees Celsius. Okay, so now I've got a beautiful scatter plot with my trend line on it. If I were doing this entire problem, if I were, say, writing this up for a group assignment, I could now just copy and paste this into a Word document. So I could say open Word. And then I'm just going to grab that, hit Control C, over into a blank document. Control V. And I've got a beautiful looking graph. Notice it's well labeled. I have both of my axes labeled. I've got a title on it. I've got my trend line and my R squared. So all of that should be in yours when you do the group assignment. All right, now let's talk about what it is we actually found. Let's talk about this line. So y equals, it was 0.403x (4013x) plus 3957. Plus 3957, I think it was. The number in front of x, that's my slope. Remember, slope is, it's y over x. It's always how much y changes for each additional x. So if we were going to interpret this, we would say the model predicts, we want to start every sentence with that, well, what's y measured in? It's a good thing we wrote that down here. What's y measured in? Degrees Celsius, the temperature. The temperature increases because it's positive by 0.4013 degrees Celsius per year. Am I spelling Celsius wrong? Oh, I guess I am. It's always y per year or per x. It's your change in y for each additional change in x. Slope is a ratio, it's a fraction. Okay, what about the y-intercept? What's that right there? That's what happens when x equals 0. What did x equals 0 represent here? The year 2000. So the interpretation of that y-intercept would be the model predicts the temperature in the year 2000 was 30.957 degrees Celsius. Okay, what about our correlation coefficient, R? Our calculator, if I'd done this on the TI-84, it would have just spit out R for me. I wouldn't have to do any work. But the Excel doesn't. It gives us R squared instead. So we're going to have to use our calculator. And calculate R, which obviously take a square root. R is the square root of R squared. But we got to be careful here. Remember, R can be positive or negative. Going up is positive, going down is negative. We got to look at the picture and see if we have a positive or a negative correlation. So I'm looking at the picture. The points are going up. My slope is positive. R is going to be positive. And that would be the square root of that number right there. So the square root, was it 7582.62? So 0.86, let's just call that 0.87. So here, I'm already in here. Positive. And we know it's positive because our line was going up because our slope was positive. So how would we interpret that? How good of a correlation is that? That's pretty strong. Remember, close to 1 or -1 is strong correlation. Close to 0 is weak. And someplace in the middle, like a half-ish or a -1/2, would be moderate. This is strong. So we would say strong positive correlation. I have a habit of spelling correlation with 2 O's instead of 2 R's. did I do here? There we go. Okay, what about r squared? R squared they gave to me. That was right there on the table, 0.7562. How are we going to interpret that? The r squared interpretation is the same every single time. It's going to be the same sentence. We're going to turn that into a percentage and say 75.62% of the variation in whatever your y's were measuring. So what's y measuring here? Temperature. This is the word you got to figure out. Temperature is accounted for by the model. So the only things you got to fit in this sentence are this word right here, which is whatever y is measuring, and that number. The rest of the sentence is always the same when we're interpreting r squared. Okay, let's make a prediction. Let's predict the temp in, oh, I don't know, what was our highest x? 13, let's say 15. So that would be the year 2015. So I'm not gonna, if I plug 2015 into this, like, let's do that. I want you to see this, because some people make silly mistakes like this. 0.4013 times 2015 plus 30 that's predicting an average temperature in Celsius of over 800 degrees. Our bones would be burning at that temperature. I might be exaggerating a little bit, but we'd all be dead. That is clearly not the right answer. X is not the year. X was years after 2000. I'm plugging in an X value. That would be X is 15. So 0.4013 times 15 plus 30. So then we would say the model predicts in the year 2015, or when X equals 15, the temperature would be 36.97 degrees Celsius. Okay, so we've got this group assignment coming up that's very similar to this. Notice here, I even tell you, I want you to do this problem in Excel and then type up everything into a Word document. I don't want you printing this off and trying to write on the document itself. There's no space in here. I've had people do that in the past, and it's just impossible to grade. There's just not enough space in here. Plus, I want to see your picture. So the easiest way to do this is type all these into Excel, just like I did here, create a graph, open up a Word document, copy the graph over with all of these details, and then answer all the questions. And then just, you don't even have to save it as a PDF, just upload the Word document. But I want you to be careful here. Look at this. Look at these years. These aren't going to do me any good. If you're typing 1971 into Excel, the whole thing's going to be wrong. Start your clock at 1970. So X equals 0 should be 1970. So then this would be X equals 1, 4, 5, and so forth. Those will be the numbers you'll have here. So you should start with years. I'm kind of doing half of it for you here. After 1970. and then just type those years after 1970. Where was it? 1, 4, 5, 8, and so forth. You might even be able to, I don't know if that's going to work here. Yeah, I don't think I'll be able to copy and paste that. Maybe there's a way to make that work, what I just did, but I think it's going to be easier just to type them. So what was my smallest? 1, 4, 5, 8. And so forth. Then be careful when you're answering the questions. Like if somebody, I don't think they ask you to make any predictions, but when you interpret the y-intercept, number 4 here, think about what that means. It is not the year 0. The post office didn't exist 2022 years ago. You're not, x equals 0 is not the year 0. One last thing I got to point out here, they don't even tell us what the rates are measured in. These are in dollars. Now, a very common mistake I see people make all the time, you'll see this at 7-Eleven. So let's say you go buy a candy bar and it costs 99 cents. I will see people write the following. That doesn't say what you think it says. In fact, I've been offering this as extra credit for years. Nobody's ever taken me up on it. If you ever go into 7-Eleven and you see a sign that says something like this, I want you to pull out your phone and start recording. This whole thing's a joke, so don't take it too seriously, but I will give you extra credit if you do it. Pull out your phone and start recording. Hand them a penny, 1 penny, and demand your change back. This does not say 99 cents. That says 0.99 cents. That says less than a penny. So not only do you get a candy bar for a penny, they owe you 1/100th of a penny back. And of course, they're not, don't steal the candy bar. It's not going to work. But I want you to make the point that that does not say 99 cents. This says 99 cents. And this says 99 cents. You either use the decimal or the cent sign, not both. So you can call that price right there 8 cents or $0.08, not both. So, like, to avoid this confusion, just don't use cents at all. Use dollars. All of these are in dollars. That's $0.25. All of your answers here, all of your sentences should be saying dollars, not cents. In fact, I'm going to tell you, if you use the word cent, or if you use this symbol anywhere in the document, you're probably misinterpreting all your numbers and you're going to get a bunch of stuff wrong. Those are not cents, they're dollars. Okay, the rest of this. Oh, let's calculate a residual. We didn't do any residuals. Okay, so let's look back at our data set. Maybe this guy right here, the 9. Let's find his residual. The point, what was it, 9, 34, 14. Okay, so residual is always the actual minus the predicted. So I know the actual, that's from the table. I got to figure out the predicted now, what the model says the temperature should have been. So I want to do I'll do it over here. Y equals, what was it, 0.4 here, 0.4013x, which is 9, plus 3957. Okay, let's type that in our fancy calculator. $34.5687. Oh wow, look at that. 345687. Almost numerical order. Okay, so there is the predicted. There was my actual. So my residual will equal actual minus predicted. Okay, let's type that in our calculator. So 34.14 minus 34.5687. I have a negative residual, negative 4287. That means that the model, the actual was above the model. The model was too low. That means if we were to draw this out, here was my actual data point, but the best fit line fell below it. There's the actual. Here's my predicted. So the model was too low. So if we were going to interpret that, we would say the model was 0.4287 degrees below the actual value. Okay, I think that should be enough help. That'll help you with a lot of these homework questions as well. Again, I would recommend doing most of these on Excel, especially these ones you can copy and paste. Instead of typing all these in and making a mistake, typing one of these decimals wrong, just highlight those two columns there, come into some kind of spreadsheet program, and then go through all those steps I did to produce the graph. It'll do the line of best fit for you. It'll give you all that stuff.